In this video, we're going to go ahead and kind of ignore this top portion. We're going to take a look at kind of the bottom half of that part of your notes. And it says, given 6 and 10, find a third number that creates a Pythagorean triple. Well, in order for it to be a Pythagorean triple, if you look at the bottom, just below that, it has to be a triangle. We know that because it told us it was. And then the numbers have to be whole numbers. So we were only given 2 parts of our right triangle. We were given 6 and 10. Well, remember a view of right triangles, the hypotenuse, kind of this diagonal side that's in green here, has to be the longest side. So that means 6 is never going to be our hypotenuse. That means 6 has to be a leg. But 10 could possibly be our hypotenuse. Okay, and that means kind of our missing term would be the other leg of our right triangle. Well, it's kind of like a guess and check. You would just have to use the Pythagorean theorem. A squared plus b squared equals c squared. Okay, and plug it in. 6 is going to represent our A, x is going to represent our b, and c is always the hypotenuse, the diagonal side. So we plug all this information in, we get 6 squared plus our x squared, because we don't know what that is, equals 10 squared. Well, we know 6 squared is 36. Plus x squared equals 10 squared is 100. You're going to subtract 36 on both sides and get that x squared is equal to 64. If you go ahead and square root both sides, we get that x is equal to 8. And there we go. We got a whole number. It goes with the Pythagorean theorem. There's our number that would make it a Pythagorean triple. It's 8. Okay. You maybe went ahead and tried it a different way. Maybe in your triangle, right triangle, you made 10 a leg and 6 a leg. Well, if you went through and did the math, you did a squared plus your b squared equals your hypotenuse squared. 6 squared is 36. 10 squared is 100. Well, you would get 136 equals c squared. If you went and square rooted both sides, 136 is not a whole number. You get a decimal. That decimal actually is 11 point rounded. It's about 11.7. That's not a whole number. So this does not work as our Pythagorean triple because we don't get a whole number. We get a whole number with this one, so that means 8 would make it a Pythagorean triple. And just remember that a Pythagorean triple is 3 sides of a right triangle, and all the numbers are whole numbers. You're allowed to have sides of a right triangle that aren't whole numbers. That just means it's not a Pythagorean triple. Pythagorean triple is just a special type of right triangle. Now, if we look at the next section of your notes, the directions say, given the 2 legs of a right triangle, we need to find the hypotenuse. Well, all you're going to do is you're just going to, again, use the Pythagorean theorem. A squared plus b squared equals c squared. So we're going to use for this section A, B, C, and D. We're only going to do a few together. So we look at A. It's just 8. And again, we are given the legs. So we're always going to plug these in for A and B. And it's always going to equal c squared. Well, 2 squared, if you plug in your calculator, 2 squared plus 3 squared is 13. That's going to give you c squared You go ahead, square root both sides. C is equal to, we know 13 is not a perfect square, and we can't simplify it anymore, so we're going to leave it in proper form. So we're going to leave it as the square root of 13. And we're going to go ahead and we're going to skip B and move on to C. They're the same. So if you can do C, you can do B. Again, we were given the legs, so we have our A squared is 4, so we're going to put 4 squared plus square root of 5 squared, and that equals our C squared. Well, 4 squared we know is 16, plus, if you plug that in your calculator, the square root of 5 squared, it's going to give you 5. Because remember, if you remember, when you square a square root, it's the opposite. So it just kind of gets rid of the radical and leaves you with a number underneath. And then 16 plus 5 is 21. And then go ahead, square root both sides again. 21 is not a perfect square. We can't simplify it, so we're going to leave it as the square root of 21. And again, D is the same way. You're just squaring a square root. So if you have the radical 4 squared plus radical 1 squared, it gets rid of the square root, so you're just left with 4 plus 1 is equal to your C squared. 4 plus 1 is 5. Square root both sides. C is equal to radical 5. Can't simplify it, so you're just going to leave it as a radical. Okay, again, this just means they're not Pythagorean triples because we're not getting whole numbers, and that's fine. Right triangles sides do not have to be whole numbers, and a lot of times they're not going to be. But if all 3 sides are whole numbers, that just means it's a Pythagorean triple. And just to sum things up, the most common Pythagorean triples are, the big one is 3, 4, 5, meaning 2 of the legs, 2 sides of your right triangle would be 3 and 4, and then the hypotenuse would be 5. Another common one is 12, 5, 12, and 13. Again, that just means one leg is 5, one leg is 12, and the hypotenuse is 13. Then another common one that you might see is 8, 15, and 17. And again, the hypotenuse is 17, a leg is 8, and a leg is 15. And kind of a helpful way to realize if you have Pythagorean triple, if you can find a common number and reduce it down, all 3 numbers by the same number to get 3, 4, 5, 5, 12, 13, or 8, 15, 17, you more than likely have a Pythagorean triple. And there you go. There's section 4.1 notes.